A very good morning to all of you. So today we are going to understand the half wave and the full wave rectifier. So we will be simulating the waveform of half wave and the full wave rectifier. Now you might have gone through the circuit diagram of the half wave rectifier. The circuit diagram is very simple. There is an input voltage and you will be having a load. So between input and the load, a diode has been connected and this is the uncontrolled switch. So now by using a step down transformer, you are reducing the voltage strength of the input voltage. We are applying a 230 volt 50 hertz. So the voltage will get reflected here and that will be given to a diode. Now this diode will become forward bias for the positive half and it will become reverse bias for a negative half. Then this will be given to a resistive load. You can go for the lighting or the lamp type of load. So this will try to simulate using a PSIM software. Now you can see that the half wave rectifier efficiency will be around 40%. We need to rectify both the half. That is why the rectification efficiency is less in case of the half wave. Now, if you want to increase the efficiency, then you need to increase the diode count of the system. In the half wave, you will be having only one diode. Now, in the full wave, you can go for two diodes or the four diode. When you are using two diode, that configuration will be a center tapped configuration, and when you will be using a four diode, that will be a bridge configuration. So we'll be simulating both this thing. Now you can see that during a positive half, D1, D2 will be turned on, and during a negative half, D3 and D4 will be turned on. So this waveforms will try to simulate in the PSIM software. So just a minute. Okay. So now the PSIM software has opened. You will be having this interface. You can search for some help also. On the left hand side, you will be having this library browser. You can search various component elements by using the find tab. Okay. So now we will go for a new file. So this will be a new file. Okay. Now we need to assemble the circuit of the half wave and the full wave using the elements which are given. Now you can easily access the element from the bottom side, or you can go to the elements. Okay, so we will be using the input voltage source. This is the sinusoidal voltage source. So when you click here, you can see that the nomenclature is going to appear here. Now I'm clicking on the square wave voltage source. That square wave voltage source has appeared. Okay, so now you need a transformer. So transformer, just a minute, transformer power. And now this is the transformer. Okay, transformer is there. You need one diode also. So for diode, you need to connect this switch. Okay, this has been connected. Then we will be requiring a resistive load. Okay, so now everything, now all the elements are on the interface. Now you need to connect using a wire. So the wire, you can see here, this is the wire. Okay, so we are joining. You can see here when you join these 2 points, a red line will appear. That means the connection is very strong. Now similarly here, okay, this I connected. Okay, has the connection has been made. Okay, so now you need to view the input and the output voltage waveform. So for that you need some voltmeter. So we will be using a voltage probe between the two nodes, or you can use a voltage probe node to ground. So voltage probe node to ground, that this is connected. Okay, here also we need to find the input and the output voltage. This one is connected, fine. Okay, so now you need to vary the values. Okay, so when you double click on the element, you can see that a small window will appear and here you can change the amplitude and the frequency also. The frequency is 50 hertz, the peak amplitude. We are living in India, so the single power outlet, the amplitude will be 230 volt, that is the RMS value. You need to convert RMS into a peak value, so it will be 312.5. Okay, so this one will be V input. If you want to display this V input onto that element, you need to click on the display. So, okay, so this has appeared. Now, similarly here also, because we want to view this waveform in the display window, so we'll be writing V input and again click on the display. Now, similarly here also, this is the output side. Okay, so again you click on the display, that V out has been appeared. Okay, now you can modify the resistance value. It is 10 ohm here, so you can change the value, but I think 10 ohm is sufficient. Now this voltmeter is the voltage probe which is connected between node to ground. So ground we will have to connect. Okay, we'll put ground here also on the primary side and on the secondary side. Okay, that is okay. Okay, the connection has been made. Now you need to simulate this, but before that you need to place the simulation control. Like in the MATLAB, you are having the power GUI block. Similarly, in the PSIM, you will be having a simulation control. So simulation control, we have connected. Okay. So when you click here, the some simulation parameters are there. Our frequency is a frequency of the circuit is 50 hertz. That is the time required to complete one cycle is 0.02, and we have set this total time as 0.01. So we need to change the value, that is to 0.4 for some some cycles. Now this is the time step. This we will keep as it is, because for low frequency this is not so much significant. Okay, so now we'll run our simulation. For running, you will have to click here. Okay, so this V input is here. We will have to add this, that is V input. You can see the input voltage waveform. Okay, so now suppose if you want to add the other waveform, then again click on this. This will truncate your window, and the next window is going to appear. So that is V output added. Okay, so this waveform has been rectified. Now similarly, you can go for the full wave rectification. You can just look here. Okay, this is the thing you need to paste it on your manual. These are the results of the half wave rectified. You can see the only the positive half has been rectified, not the negative half. Okay, so now similarly you can go for the full wave rectification. Okay, so again we will be using the input voltage. So sinusoidal voltage source will be there. Then we will be adding a diode for that. Okay, where is the diode? That is the element, then the power and the switches. So this is the diode. Okay, this one is diode. Because this is the full wave rectifier and that too in the bridge configuration. So you will be using a 4 diodes. Okay, so now again you will have to make a connection, but before that, please add some resistance into it. Okay, so this is the resistance. Okay, because we need to find the output voltage across this resistive load. Now make a connection using the wire. The connection has been established. Okay, uh, right. This is will be in the bridge configuration. So make a strong connection. Only then the current will flow. Otherwise, there will be no current. And when there is no current, there is no output voltage. Okay, this is sufficient. Um, okay. Now we will be using this voltage probe between the two nodes. Okay, and similarly we need to find the source voltage and the output voltage again. Again the connection is required. Just a minute. Okay, Now this is okay at the source voltage side. You see, can when the connection is not met, then the green color is going to appear. Okay, right. Now you need to vary the values of it. So that will be 230 or you can say 302.5. That will be the peak amplitude. This is V. But now here you will write V source. Okay, that is V source. Now we will give some name to this measuring instrument. That is V. A source only we will write. We will click on the display because we need to put that V source onto the element. Then a resistive load 10 ohm is sufficient. Then this is the V output. Okay. But here we have already used V out. So what we will write? We will write V out 1. Now click on the run simulation. Okay, so you can see here now we are having four variables. Two variables are of the half wave rectifier and two variables will pertain to your full wave rectifier. So this V source. Okay, now we will be using, we want to see the output voltage of the full wave rectifier. So you can see here, you can see the waveforms of the output voltage of the full wave rectifier in the previous half wave rectifier. In the previous half wave rectifier, only one half was rectified. You can see, I'll write then this is the output. Okay, so in the same in the same window, we have obtained the result for half wave and the full wave rectifier. The upper two waveforms are pertaining to your full wave rectifier, and the lower two waveforms are of the half wave rectifier. You can see here this half wave rectifier is not going to process the negative half, and because of that, the efficiency of half wave rectifier will be around 40%, and the efficiency will be doubled when you use the full wave rectifier. The only drawback this will be having that you will have to use four diode instead of only one diode, because diode is a unidirectional device. The diode can conduct only in one direction. So this is all about the half wave and the full wave rectifier. So we'll meet in the next video with a new experiment.